Average speed and instantaneous speed we have already seen in the previous video. Now we will plot the distance s as a function of time. X-axis is t, y-axis is s. So we are plotting now graph between distance and time t. Suppose this is the graph. This graph shows the relationship of distance with respect to time t. At different time, we can see the distance traveled by the particle. Different time instants, we can see the distance traveled by the particle by plotting the coordinate. Suppose we want to find at time t what is the distance traveled. So at time t we will draw a perpendicular which will touch the graph at point A. So this distance, this length will show the distance traveled at time t. Similarly, suppose after time t plus delta t, we want to know the distance traveled by the particle. Again we will draw a perpendicular line and we will see where it touches the graph. It touches the graph at point B. So this distance is this length shows the distance traveled at time t plus delta t. One thing more, if we want to know the instantaneous speed, at any time t, then we can draw a tangent at this point on the graph. The slope of the tangent, suppose tangent at this point we draw, this is the tangent, the slope, that is tan theta, is the slope. So tan theta will tell us the speed at time t. The value of tan theta gives the speed at instant t. Suppose we want to know the instantaneous speed at t plus delta t, then we will plot a tangent at this point and see where it touches the angle alpha. So tan alpha is the speed at time t plus delta t. This is the speed at time t. Now, how it comes? How the slope is equal to speed, we will see. Now suppose we want to know the average speed between point A and B, that is from time t to time t plus delta t, it has traveled some distance. If we want to know the average speed is distance traveled by time taken. Already we have seen in previous video. Now distance traveled in this time interval from t to t plus delta t is how much? That is this distance minus this total distance and total time taken, that is t plus delta t minus t is the total time taken. One thing more we can see here, if we draw this horizontal line, we will get this length equals to this length. This is suppose delta s. This is s. At time t, it has traveled distance s. This is equals to this. At time t plus delta t, it has traveled how much distance? This much distance. This is how much? S plus delta s. So what is the net distance traveled? Net distance traveled is this length minus this length. S plus delta s minus s. And total time is t plus delta t minus t. That equals to delta s upon delta t. So we have seen the average speed equals to the slope of the chord AB. This is a chord AB. AB. What is the slope of this chord AB? This is the slope. This is the slope. Suppose this is alpha or beta. So we see here slope of chord AB. Slope of chord AB equals to what? Tan beta. What is tan beta in this triangle? Tan beta is perpendicular upon base. What is the perpendicular? Delta s. What is the base? Delta t. This is t plus delta t, this is t. So this is delta t. So what we see here? We see here average speed equals to delta s by delta t, and slope of the chord AB is also equals to delta s by delta t. That means average speed equals to slope of chord AB. This we have seen now, that if any graph is given between distance and time, and at two points we want to know the average speed, then the slope of this chord will give you the average speed. Now suppose this delta t is very small, almost equal to 0, then this point will shift nearer to this point, and this point will also shift nearer to this point. So we can see here that chord AB becomes what? Tangent at point A, and the average speed delta s by delta t becomes the slope of the tangent, which is ds by dt. So instantaneous speed equals to slope of the tangent. What is the slope of the tangent? Tan theta, and that equals to ds by dt, because delta t is almost equal to 0, delta s is very small. So this is limit delta t tends to 0. This equals to ds by dt. If the speed of the particle at time t is v, the distance ds traveled by it in the short time interval t to t plus delta t is v dt. If the speed of a particle is v at time t, then what is the distance traveled? We know here that speed equals to ds by dt. Therefore ds will be equal to v into dt. So if the speed of the particle at time t is v, the distance ds traveled by it in the short time interval, that is dt, is v into dt. The total distance traveled by the particle in a finite time interval t1 to t2 can be obtained by summing over the small distances ds as time changes from t1 to t2. So suppose we want to know time t1 to t2, how much distance it has traveled. What we will do, suppose this is the total distance, time t1 to t2 it has traveled. So we will divide it into small parts. A small part here, suppose this is very small distance ds. ds equals to v into dt, small time interval dt. Now like this dt, there are so many dt, small dt. If we add all this, we will get total distance. This is one ds, this is another ds, another ds, another ds, another ds, another ds. So there are so many ds, small ds. This whole distance s we have divided into small distances, that is ds. And if we add all the distances, we will get the total distance. This is done in calculus like this: ds integration. What is ds? v into dt. And time is varying from t1 to t2, t1 to t2. So if you integrate v dt from t1 to t2, you will get the total distance from t1 to t2. Now we'll see a graph between time t and velocity v. Earlier graph we had seen, it was between distance and time. Now we are seeing a graph between velocity and time. Velocity and time. Suppose at time t1, this is the velocity. At time t2, this is the velocity. This is a graph. This graph shows the relationship between velocity and time. At time t1, this length shows the velocity. At time t2, we draw the perpendicular, this length shows the velocity. Now we have seen here that distance traveled is integration of v dt t1 to t2. So it means distance traveled we can find out by this area. This area gives us the distance traveled in time t1 to t2. Suppose this is one time t, and after dt time, this is the point. So this is a rectangular bar. What is the area of this bar? Area of this bar is, this is v, velocity. So velocity into time. This is the area of this rectangle. Similarly, this is one rectangle, this is another, this is another, this is another, this is another. So there are so many rectangles like this. So we have to add all them. All we will add. We don't know how many are there. So this is the job of integral calculus. If you write like this, it means all added v dt. and from dt means from which time to which time, t1 to t2. This is the total area and total distance, because velocity into distance is nothing but distance. This is ds, this is another ds, this is another ds. So all ds we are adding, so we'll get total ds, total distance. So s equals to integration of t1 to t2 v dt. So if you are given a graph of v and t, the area between this graph x-axis and the two ordinates will give you the total distance traveled. Now, what is the dimension of velocity? Dimension of velocity is L t inverse 1, distance traveled by time, and its SI unit is meter per second. Now one example we will see. It says that speed versus time graph is given. Speed versus time graph is given like this. So this graph shows the relationship between velocity and time. At time t equal to 0, velocity is 0. Time t1, velocity is 1. Time t2, velocity is 2. Like this it is varying. Time 3, velocity is how much? 6. Now the question says the distance traveled by the particle from 0 to 3 seconds. Now just now we have seen distance traveled equals to what? Area under this triangle, area of this graph. What is the area of this triangle? Half into base into height. What is the base? 3. What is the height? 6. So it is 9. Thus the particle covered a distance of 9 meter if this graph is given to you. Thank you.